Okay, so let's talk a little bit about the course, and then we come back to talking about God. First things, we are running today NASA Space Apps Challenge. You probably know about this. It's a kind of like a hackathon, but you can create a game, you can create an app, you can create sort of a multimedia presentation of some sort, and it will run from today from 6 o'clock all the way to morning of Sunday. And we are providing food. We will have some judges, and those teams which kind of do good job will compete on the global Space App Challenge in US against the other international teams. So if you're interested, you can still sign up. You can just come at 5 o'clock and register in front of K109 and take part in it. I think it's gonna be some kind of fun event, and the local cyber range is sort of organizing it and paying for food and kind of supporting it. So if you go to spaceappschallenge.org, you can find Jovik, and we are the only ones. I think we are the only ones in Scandinavia, although I think there is a team from Estonia which runs as well. There is a preliminary program, and you can contact me or just come at 5 o'clock to K109. So that's one thing. The second thing is we have next week the final of the coding challenge. So those of you who are keen on doing some crawler in Go, please consider it. Please use the weekend maybe and do a crawler as specified in the code challenge 1, and submit to me the URL to your repo and the HTML directory which you have your files in. So we will do the kind of a competition on the lecture next week on Tuesday. Depending how many submissions I will get by Sunday night, I will possibly spend Monday either automating it or we just do it by hand. So if I have, just few submissions, we just test them by hand. But if I get more than 5, let's say, I will write a little tool which will kind of go and check all of them kind of automatically. So we can check who get what points. So yeah, hopefully those of you who are thinking about it will submit it before Monday. But yeah, you can submit Monday as well. And then on Tuesday we will kind of run the tests. The idea is that we're kind of competing of how clever your crawler is against other crawlers and how clever you are in hiding the IGC file URLs in your HTML. So it's a little bit of a game, like a kind of a puzzle, I would say. All right, so those are two main things. The third thing is I've updated the lecture notes. So for today, I posted 2 lectures from last year. One is quite okay. It goes over the MongoDB usage and explanations, a little bit extended and a little bit more with Go to what we did on the last lecture. And then the second part of it, it's kind of rewriting the in-memory student store that we've used last year for explaining some of the Go concepts into interfaces. It's okay, it's a little bit slow, and I reviewed the video this year and I'm kind of I'm getting stopped at few places with some of the challenges of dealing with interfaces. So the video is a little bit slow. You may kind of need to play it like 1.2, 1.5 speed. Yeah, exactly. So this one is especially slow. So apologies for that, but yeah, if you fast forward it, it has the content that you need, and it kind of explains how can you change your dealing with directly with structs into dealing with interfaces instead, and it kind of provides you a robustness of changing the underlying implementation. So we use interfaces for separating how we implement things to how we interact with things, right? So a Go interface is simply a set of method signatures that something implements, and unlike Java or other programming languages where we have to be very explicit about which structures extend particular interface, in Go it's sort of it happens implicitly. So if something implicitly implements particular interface, then you can put it in that slot. So it allows you to nicely separate details of the implementation from the way it is being accessed, right? So in the examples in the lecture, what we did, we had student DB, which was basically a simple in-memory storage facility, and we were interacting with it via 4 or 5 methods. And then we wanted to make it a persistent storage, but we didn't want to change our, handlers which were dealing with the database. So what we could do, and what we did, we changed the struct into a set of methods in the interface, and then we re-implemented the same logic with the persistent storage. And then the beauty is that you can pick at runtime which one you want to use. For testing, you can use the in-memory one. For deployment, you can use the persistent one, and so on. So using interfaces is kind of a nice way of isolating your implementation details from the way something is using it, right? So those 2 lectures kind of go into that. And then today I'm recording, and I will put the link to this video about the peer review. So we started doing peer review last year with the mobile course. We don't have a system yet, so we're really using very low-tech solution for this. So I think it will be the last time we're using this low-tech solution because it has some appeal. I like it because it's very verbose and very intuitive, and it relies on trust. But because of those reasons, there are some limitations as well. So what we will do, we will probably change it for assignment 2 and for the project to something more automated. But for now, it's a very low-tech solution, which is basically a spreadsheet. It's an open spreadsheet, which you will find in assignment 2 bottom of the text. And it has your code, your student codes as numbers, okay? 2 students, I couldn't get those codes from the Blackboard. So you have to put your own codes at the bottom. So if you cannot find yourself, those 2 students will know who those are. If you cannot find your ID on the list, you have to add it. There are actually 2 like empty slots where your username was sorted by, and then you can just put it there. So one student is kind of in the middle, and one is towards the end of the list. And then what you do is you have few columns. So for each of you, you will want 2 reviewers to check your code and grade you. Okay, the grading is from 0 to 100. If you've done everything, you will get 100. If you are missing something, the reviewers will give you a little bit lower score. And then there is a field for comments, and then you can specify why something is not 100. Or you can tick that somebody did more than necessary, and then explain what that extra work was. Okay, so I don't want to show it, like you can open it now on your laptops. I don't want to kind of record it in the video on YouTube. But you can open the spreadsheet and you will see those columns. And each reviewer has 2. So you have to put your code, who you are, and then the score. Who you are, the score. And then the explanations are joined, right? So both reviewers use the same field for explanations. So you can, I don't care whose explanations are at the comment section. So what it will end up with, for each row, you will have 2 reviewers' IDs which marked your work, and then those reviewers can check on the first sheet how many reviews how many reviews they've done. Okay, so if someone was using your ID without you knowing it, you will know, because you know that, for example, you've checked to work, but the number says 3, right? So you will see, okay, something is not right. So that's why this system relies on trust, because you can verify yourself if someone is kind of trying to reuse your ID for marking somebody else's work. Does it make sense? Yeah. We kind of expect everybody to mark 2 other people's work, because you need 2 reviewers to mark your work, right? So to be fully reciprocal, you have to mark two work as well. Last year, it turned out that we had actually a distribution, kind of a nice Gaussian distribution. So some people were marking nobody, and some people were marking like 8 or 10 people, okay? So it was kind of bell-shaped, with some, let's say, free riders not marking anybody, and then some people being kind of active and marking a lot of people. Try to not do that, okay? Try not to be a free rider, so try to mark somebody else. And if you've already marked 2 people and someone asks you, okay, you can help, but you know, don't go around and say, oh yeah, I can mark you, right? So, because if you mark 20 people, then other people cannot mark anybody, so they will naturally become free riders, right? So if someone asks you, okay, do it, but don't kind of proactively try to hike your counts too much, just to balance it. But of course, there will be some natural free riders which will try not to mark anybody, I guess. Right, so this is it. What I will do after this speech, I will add another spreadsheet into the sheets that we have, and I will put for assignment 1 like a checklist, okay? So I will put a couple of points which the specification requires for the task to have, and you can modify it. You can add your own at the end, and this will be like a guideline for how to do the marking, okay? So for example, that if you do /API, it should show you the count of how long the service was running, and so on. So we have kind of, in the spec, we have a couple of tasks. So I will isolate them into a spreadsheet so it's easy to follow. It will be kind of like a point 1, point 2, and so on, right? I will do this, and then you can add your own if you think I missed something, okay? Or if something was sort of important to test. For convenience, the first column is the repo URL, okay? Technically, if you have 2 markers, you don't really need to disclose your repo URL actually publicly. But we will verify some of the entries ourselves. So the tutors and we, I mean myself and Christopher, will check the submissions as well. Maybe not everybody, but we will do that. And it's convenient for us if the repo URL is in the spreadsheet, because then we can kind of go directly to the repo and do the tests. Otherwise, we have to go from the user code to the submission system that we have to find the repo URL. We can do that, so if you don't want to like publicize your repo URL, don't put it there. But if you don't care, then put it there. There was a question last night if we have to do peer review physically, being in the same room. No, we don't. But then you have to share the URL with somebody who is not with you, and then you have to grant them access to your repo, right? So if you are doing a peer review with someone in the room, you don't have to grant them access to the repo. You just give them the computer and they can browse your repo themselves, and they can run the stuff and test it, right? So then you don't have to publicize or disclose or grant access to your repo. Your repo can be private and you don't kind of share it. But if you're doing it remotely, you have to effectively share your repo URL with somebody else and grant them permission. It's not a big deal. I mean, it's a kind of student exercise, so, but it's up to you, right? If you want to do it remotely, fine. If you want to do it face-to-face, fine. Just remember that, you know, someone needs to have access to your repo if you're doing it remotely. What else? The scoring is up to you. So as I said, if someone did everything, you gets 100. If someone did everything plus something extra, gets 100 with that extra tick yes and explanations what's extra. If someone is missing something, like, I don't know, the deployment on Heroku doesn't work or something, right? Then judge yourself, like how much work was that, and kind of deduct the score. Don't use floating point, use you know, from 0 to 100 with just integers for sanity's sake. But it's entirely up to you, right? With the border cases, we do our marking as well, right? So if someone doesn't get 100, we will check it as well. If someone gets 100 with extra, we usually check it as well. So if someone just did the exercise and it's just 100 and everything is like normal, then we probably will not check it, right? Because that's majority of the cases. So again, usually it's a Gaussian curve. Most people just do what's needed. They get 100 or really close to 100, and that's the end of the story. Yeah, I think that pretty much covers it. Yeah, and I forgot about something? Yep.
The testing, I think, is going to be very varied.
Yep.
From each submission. So, like, should we just check how extensive the tests are, like, or before we give them a score?
You mean the actual tests?
Yeah.
Yeah. So let me just check.
So it just says like I supply, like there's tests submitted, like. I don't think tests are specified.
No.
When the submission form.
Yeah, it was on the submission form, but it is kind of part of the extra, okay? So, yeah, so if someone has tests, then you say, okay, yes, for extra, and then say, okay, how extensive the tests were, right?
My test document is almost bigger
Than the actual submission. Yeah, so then you will get like a very extensive testing, right? It's good if the, I will put into the, I will put as one of the rows in the kind of a checklist, what's the test coverage, right? So giving a test coverage already gives us kind of an indication how extensive the testing is. So if, you know, the test coverage is 100, then it's like, okay, someone really paid attention to doing the testing, right? So we will have it from the kind of a checklist. But then you use the comment field to kind of specify that. Yeah, that's a good point. The testing wasn't compulsory in the assignment 1, so it counts as extra. It is compulsory for assignment 2, I believe. If it isn't, I will make sure it is. We had last year, we had kind of a targets for the test coverage as well. So for the assignment, sorry, for assignment 2, I think we had 40% at least. And then for the project was like 60 or above 60. So we will do the same this year for assignment 2 and the project, but for assignment 1, yeah, it was an optional feature. If people did use Google and Heroku or did something kind of out of ordinary, then put it in the comments, right? You don't have to write the details of the checklist. You only need to kind of run through the checklist and comment on unusual things, right? Okay, any other questions? Okay, so what I will do is I will update the checklist. You can add your own things if you feel I missed anything, because it is sort of like a communal thing. Don't mess up with the spreadsheet. Don't delete stuff from the spreadsheet. Check the sanity of the spreadsheet with your ID. Yeah, that's pretty much it. And remember those 2 students who are not there to add yourself in. Yeah, the weird thing was on Blackboard, I had everybody, like I have the list for the class, and I have everybody as, you know, name, email address, the student username, and the code. and so on. And for 2 students, I was missing the code. I had everything apart from the actual student code for some reason. So you have to use that because we're using that. It's the most, yeah, it's kind of security by obscurity, like, because it's really hard to work out who is who by just looking at the numbers. Not ideal, but the best for this sort of an open system. All right, so that's all. And we spent the rest of the class doing the peer review. If you have any questions about assignment 2 or about the coding challenge, I'm around, so we can chat.